Hello, chemists. Today we're going to be talking about two things. We're going to be talking about dilution factor and the common ion effect. First off, the dilution factor is a way of working out the concentration of a solution after you've added it to a supply of another solution. So you've got a big beaker of something and you add just a few drops of something else, and you want to know what the concentration of the thing that you added in the whole thing is. There's an equation for that, and it is this that you see right here. The concentration of the whole new thing is equal to whatever your original concentration was times the volume of the original stuff you added, and then the volume of everything, new stuff and old stuff combined. So if you're adding a few drops of something to a big beaker of something, you want to know how much volume of stuff did I add, the volume added, how much is the total volume after I added the stuff, and what is the concentration of my original thing. And that'll tell me the concentration of my new thing. It can be adding drops to pure water. It can be adding drops to a solution of some other chemical. If you're adding uh, solution of one concentration to another example of that same solution at a different concentration, um, that'll give you something else. But we will talk about that later. Okay, that is dilution factor. It's pretty straightforward, and we'll have some practice on it. Next is the common ion effect. Common ion effect is what it says here is a common ion effect is the effect that occurs when an ionic compound is added to a solution which already contains an ion in common with that of the added ionic compound. That is gibberish to me. Doesn't make a ton of sense. Let me try to break it down. The common ion effect occurs when, okay, clear enough, an ionic compound, okay, so let's say sodium chloride, is added to a solution. So, okay, we're adding the sodium chloride to something else, which already contains an ion in common. So we're adding it to something that already contains some sodium or chloride. Basically, adding something to something that already contains part of the something we're adding. And that will cause equilibrium to shift, because we know from our previous work with Le Chatelier's principle that if we add something to a reaction at equilibrium, it will shift to counteract that addition. If we add more reactants, we'll end up with more products as well. If we add more products, we'll end up with more reactants. The common ion effect, and the common ion effect is especially relevant when we're dealing with slightly soluble salts. Slightly soluble means only a little bit soluble, only dissolves a little bit. All right, here's an example. Take this equation here. So silver chloride is in equilibrium with silver and chloride in solution. If silver chloride is added to a solution which already contains the chloride ion, the silver chloride you're adding has an ion in common with the stuff you're adding to it. That solution will contain ions from the following sources. So here's what's overall in that stuff. The silver that you're adding, the chlorine that you're adding, and the chlorine that was already present, that there. So there's three things present. And because this is at equilibrium, we have to use this K sub S equation. K sub S equals concentration of silver times concentration of chloride. All right, so all of these things are true. Okay, what does that mean? So just carrying this over from the previous page so we are keeping it in mind. K sub S equals concentration of silver times concentration of chloride. If we've increased the concentration of chloride by adding that silver chloride, then the silver in the solution will decrease to make sure that K sub S remains constant. This here, bit right here, make sure that K sub S remains constant is important. K sub S is a constant. K sub S does not change. I want you to imagine K sub S being nailed down, made of stone, made of steel. K sub S does not change for a given thing. So if we change anything about the reaction, say for instance, changing the concentration of the chlorine, we know that this is not going to change. So in order to keep that the same, this must change. Okay. So if we means that less silver chloride will dissolve in a solution already containing chloride ions than will dissolve in water. Basically, what it means is because the chloride is already there, there's no more room for more chloride in the solution, even though there's room for the silver. Because in order for this silver chloride to dissolve, it produces one silver and one chloride. There's no room for the chlorides, so that means that the silvers don't fit either. The chlorides being in common causes the silver to not dissolve. All right. In summary, when an ionic solid dissolves in a solution which has an ion in common with the solid, the solubility of the ionic solid dissolving is reduced. Again, this is one of those gibberish things. So let me break that down a little bit more. When an ionic solid dissolves in a solution, so say sodium chloride, table salt, is dissolving in something else, which has an ion in common with the solid, say it's got a sodium or a chloride already in there, the solubility of the ionic solid dissolving is reduced. So if we're trying to dissolve sodium chloride in something that already has sodium or chloride, not as much of the sodium chloride will dissolve because there's not, I say room, there's plenty of space, but there's not, the equilibrium expression doesn't allow that to dissolve that much. Okay, next thing, the solubility of a solute in a solution involving common ions is measured by the concentration of the ion, which is not the common ion. So when you're talking about how soluble the solute is, you're measuring how soluble is the thing that is not the common ion. So in our silver chloride example, we would measure the solubility of silver chloride by the solubility of silver. The reason why is the solubility of chloride gets really complicated because it's difficult to tell which chlorides come from the silver chloride and which chlorides were already there. So we measure it by the other thing, by the silver in that case. So for example, if hydrogen chloride is bubbled through a saturated solution of calcium chloride, the addition of chloride ions from this hydrochloric acid, hydrogen chloride, sorry, will cause solid calcium chloride to precipitate out. Because the chloride ions are going in, the calcium chloride becomes less soluble. The common ion, the chloride between the two, decreases the solubility of the calcium. Decreases the solubility of the calcium that is associated with the chloride. Thank you very much.